Okay, so this is our next problem that our grammars are going to face. So which is the left recursion. Now, just have a look at this. So once we explain the examples, I hope you will be very clear what is this left recursion and how we are going to remove. So before going to look into the examples, let us observe that if we have a, see, when can we say that we have a left recursion associated with our grammar or not? The idea is very simple. Just have a look at this. See, whatever the symbol which is appearing on the left hand side of the production, if the same symbol appears as the first symbol, as the first symbol on the right hand side of the production, then we can say that that grammar is having left recursion. Okay, so let us have a look at this. So let me repeat the statement again. The symbol which is appearing on the left hand side of the projection, if the same symbol appears as the first symbol in the right hand side of the projection, then we can say that that projection is having the left recursion. Okay, now if we have the left recursion associated with the production, then immediately what we have to do, we need to remove the left recursion present in the grammar. So how do we remove the left recursion present in the grammar? So for that, so these are the steps that we are going to follow. So what we are doing now, we are going to rewrite the same grammar in a different way. Understand? So now we are going to rewrite the same grammar in a different way. How we are going to write? So A derives to beta. So this is the beta part. We are not worried about what we are going to have in a beta part. So we are going to take this beta part, beta A dash. So A dash is a new variable which has been introduced in order to remove the left recursion present in the grammar. Okay, so beta A dash. And what about A dash projections? A dash refers to alpha A dash. What is alpha? You can see here we have an alpha part over here. So that alpha A dash or epsilon. Alpha A dash or epsilon. Understand? So just have a look at this. So everything which is required to simplify or to remove the left recursion present in the grammar, everything is available over here. So we have a prediction called A derives to A alpha or beta, so which is a left recursive grammar. Now, in order to remove the left recursion present in the grammar, we need to rewrite the predictions. So how we are rewriting? We are going to write something like this. So A derives to beta A dash and A dash derives to alpha A dash or epsilon. And coming back to this alpha and beta, so all these are available in our given grammar itself. Okay, so this is one type of grammar like where it has been involved in left recursion. So sometimes it is also possible that you might get a grammar which will be like this. Please try to have a look at this. Sometimes it is also possible that you may get a grammar which will look like this. What is that? A derives to A alpha 1 or A alpha 2 or A alpha 3 and so on, followed by beta 1, beta 2 and so on. Okay, in such cases, so how do you remove the left recursion present in the grammar? So we are going to follow the same approach. What is the same approach? Here we have beta, just a single beta is there. So we are going to use beta and a new variable called A dash. But we have multiple betas over here. So hence what we are doing, we are going to use beta 1 A dash, beta 2 A dash, beta 3 A dash and so on. Okay, and coming back to A dash predictions, so in the above case we have only single alpha, so we have written alpha A dash or epsilon. But here coming back to A predictions, we have multiple alphas. That is the reason we get alpha 1 A dash, alpha 2 A dash, alpha 3 A dash, alpha 4 A dash and so on, followed by epsilon. Okay, now this is how we are going to remove the left recursion which is present in the grammar, right? Now let us take one simple example. We have two examples over here. Now we try to remove the left recursion which is present in the grammar. Okay, so let me take the predictions over here. So three productions. Okay, so we have a first production e derives to e plus t or t. Now we need to check. First, we need to check whether there really exists some left recursion or not. Then this is our second production, and this is our third production. This is our third production. Okay. Now let us check. Let us check whether this grammar is a or this production is having left recursion or not. And let us check this one also and this one also, so that we can remove the left recursion present in the corresponding grammar. Now you can see here what is the symbol appearing on the left hand side of the production, capital E, and what is the symbol which is acting like a first symbol on the right hand side of the production, which is nothing but capital E. So this E and this E both are same. Now we can say that so this production is having left recursion. This production is having left recursion. So which is nothing but now it is available in this form. What is that form? This is the form. Okay, so now it is available in this form like a derives to a alpha or beta. So we have a derives to a alpha or beta. Okay, now here, so what is our solution? Our solution is like this: beta a dash, alpha a dash or epsilon. Now we need to remove from here. Now here, as per this formula, so when you apply to this production, now can you please guess what might be A here? A will be equivalent to, A is equivalent to capital E, and then we have alpha and beta. So let me copy this. So alpha and beta is there. Now can you guess what is alpha now? Please observe what is alpha. So please observe we have a production. This is A, and this entire part, whatever follows A, please observe this is A, and whatever follows, then it will be considered like a alpha. So alpha will be plus T. Alpha will be plus T. And what about beta? So we have on the other side, so this is only left. So capital T will be beta. So capital T will be beta. Okay. Now we got capital A, alpha and beta also. Now we need to write down the solution for this. So what is our solution now? A derives to beta A dash. What is A now? Capital E. Capital E derives to what is beta? What is beta? Beta is capital T. What is A dash? A is E. So it will be E dash. So please observe A derives to beta A dash. What is A here? Capital E. What is beta? Capital T. A dash in the sense E dash. Okay. Now here A dash in the sense we get E dash. Alpha is, what is alpha? We have plus T. We have plus T. Plus T. A dash in the sense E dash or epsilon. Or epsilon. Understand? So this is how we are going to remove the left recursion which is present in my production. You can see here. So this is the result which we are going to get after removing the left recursion. Okay. Now let us go ahead and see the second production. What is the second production? T derives to T star F or F. This is how we have a production. So what is the symbol appearing on the left hand side? Capital T. And if you go for the right hand side of the production, what is the first symbol appearing on the right hand side of the production? Capital T. Now this symbol and as well as this symbol both are same. Now from this we can say that this production is also involved in a left recursion. So it is also involved in left recursion. So hence again what we have to do now, we need to remove the left recursion present in the grammar. Okay, so this time we have a different grammar. So as per our formula, so what is this? Capital A is capital T here. Capital T. So A is T now. Okay. And what about alpha? Alpha will be star F. Alpha will be star F. And what about beta? Beta is a capital F. So it will be capital F. Now what about this here? So here you will be getting A is capital T, T derives to beta A dash. What is beta here? F A dash. A dash is capital T dash. Okay. And A dash refers to alpha A dash. What is alpha here? We have star F T dash or epsilon. Star F T dash or epsilon. Okay. Then so from this we can say that yes, we have removed the left recursion which is present in our second prediction also. Then go for the third prediction here. What is the variable appearing on the left hand side? Capital F. The variable appearing on the right hand side is ID. So now these two are not matching. So now we can say that so no left recursion is present in this prediction. Okay. So finally we can say that for this given input grammar, the corresponding output grammar will be after removing the left recursion. So let me write after removing left recursion, the grammar is. So what is our grammar? We need to write these productions. So E derives to T dash. So we have to write these productions. Okay. Then T derives to these productions, T productions. And after that, we have a production called F derives to IT. So where it has not been involved with any left recursion. Understand? So this is how we are going to remove the left recursion which is present in our given grammar. Okay. Now let us go ahead and we will see one more example also. So here, okay. So this is our one more example. Let us have a look at this. Let me take a table. Okay. So this is for our first production. So this is our second production. Second production. So just have a look at this. Please check what is the first production. This is our first production. The symbol appearing on the left hand side is a capital S. What is the symbol appearing, first symbol appearing on the right hand side of the production, which is a left parenthesis. So there is a mismatch. Clearly there is a mismatch. Now we can say that, so this production is not having left recursion. This production is not having any left recursion at all. Okay. Then go for second production. What is second production? L derives to L comma S or S. You can see the first symbol appearing on the left hand side of the production is a capital L, and on the right hand side we have first symbol which is also capital L. Now we can say that so this production is involved in left recursion. It is involved in left recursion. So what we have to do now? So we need to follow the C. So A derives to this formula we need to apply. Okay. So let us go ahead. And here, what is A now? So this is A, and this is comma capital S is alpha, and this is going to be beta. Okay. So A is capital L, and alpha is comma capital S, and beta is also capital S. Then here we will get A derives to A in the sense capital L derives to beta A dash. What is beta here? Yes, A dash, in the sense L dash, S L dash. And what about here? So L dash there is to alpha A dash. What is alpha here? Comma S, comma S, comma S, A dash in the sense L dash or epsilon. Okay. Then after removing our left recursion, now the grammar will be like this. So what is our grammar? So we will get the prediction, this prediction straight away as it is, because it has not been involved with any left recursion. And here we are going to get this prediction, new prediction. So these are the two new predictions which we are going to get. Okay. So let us make different color. Okay. Now let us see here. So this is what the grammar which we are going to get after removing the left recursion which is present in the given grammar. Understand? So this is how we are going to check so whether the left recursion is present in our grammar or not. If it is present, and this is how we are going to remove the left recursion present in our grammar. Okay, so this is the one of the problems that the parser which we are going to use inside the compiler, it is going to face. So that is the reason why whenever we are going to give some input, I mean some grammar as input to the grammar. So first of all, we need to make sure that the grammar is not ambiguous, and at the same time the grammar is not having any left recursion as well as a left factoring. Okay. Now, as part of our ambiguous part, so first we discussed about the ambiguity. Then the second one which we covered just now will be the left recursion part. Now let us go ahead and see like how we are going to remove the left factoring present in the grammar. Okay. Now please have a look at this. So whenever we want to remove the left factoring, the idea is very simple. The idea is very simple. Just have a look at this. See, we have some input grammar like this. So this is my input grammar. So this is my input grammar. And after removing the left factoring, after removing left factoring, so my grammar can be like this. Left factoring, my grammar is going to look like this. See, have a look at this. So whenever there exists a grammar called capital A there is to alpha beta 1, alpha beta 2, alpha beta 3, and so on, alpha beta n, followed by a gamma. Now please have a look at this. So what is the common thing which is available on each and every production? You can see here in the first production we have alpha comma. In the second production we have a alpha common. Then in the third production also we have alpha common. And at the same time in the last production also we have alpha common. That is the reason why, see here, what we are doing is we are going to rewrite our production in such a way that A derives to alpha, so which is common. Please observe this alpha is common in our all productions. So hence we have taken this alpha straight away, and in the place of this beta 1, beta 2 and so on, we are going to make use of a new variable called capital X. So I have taken capital X as a new variable. It is up to you, like you can go for making use of any variable. Okay, so here I have introduced a new variable called capital X, and this gamma is going to come straight away. Why? Because this gamma is not started with the same variable or same symbol which having alpha. Okay, so that's the reason why. So this prediction will be rewritten like this. And now we need to specify what is this capital X is. So this capital X refers to this one. What is that? Beta 1, beta 2, beta 3, and so on up to beta n. Understand? So the idea is very, very simple here. So first you need to consider all those symbols so which are common in all the productions. Now using that production, just write down the symbols which are common in the form of alpha, and then we need to introduce a new variable called x. Now whatever the symbols which are not common, or whatever the substrings which are not common in each and every production, so all those substrings are going to come as part of this new variable called capital X. Right? Now let us see some examples so that it becomes very clear for us in understanding what is this left factoring is. So first of all, have a look at this grammar. So first go for this grammar. So let us take that we have a grammar like this: S derives to small a capital double S B capital S, or A capital S small a capital S small b, or A small b and b. So this is what the grammar is. Now, as it is a left factored grammar, now we need to search for, or we need to look for, so such a pattern so which is common for all the productions. You can see here. So what is common for our productions over here? You can see we have small a which is common. So here also small a is common, and here also small a is common. Right? Now, can I consider it like alpha? This is like alpha, and this is beta 1. Now, this is alpha, and this is beta 1. And this is alpha, and this is beta 1. And this B is gamma. This B is gamma. Now, let us write the same over here. Now, I am going to take the same grammar. So, this grammar is like this. So consider about this. So we have a prediction like this, and this is our solution after removing this. After removing left factoring, we get the solution like this. Okay. Now here we need to specify what is alpha and A is. So where A is capital S, capital S, and we need to specify what is alpha is. So alpha is, you can have a look at this. Alpha is, what is alpha? We have taken small e. We have taken alpha as a small e. And what about this one? We need to specify this beta 1, beta 2, beta 3, and gamma part also. So let me copy this entire one. So we have beta 1. So if small a is alpha, whatever the remaining is there, it is going to act like a beta 1. So beta 1 will be this one. Okay. Next we need to write what is beta 2 is. What is beta 2? If this is small a is alpha, then this will be beta 2. So I am going to copy this. So paste it. This is beta 2. Okay. Now we need to look into the third one, which is beta 3. So what is beta 3? If this is alpha, and what about beta 3? This is going to be beta 3. So this is beta 3. Okay. And then if this is beta 3, and the final one which has been left is a gamma. Which has been left is a gamma. So now we are going to write what is gamma is. Gamma is small b. Gamma is a small b. Okay. Now we have capital A, alpha, beta 1, and so on, gamma also. Now substitute all these things over here. So here what we get, A derives to alpha x or y. So A is nothing but capital S derives to what is alpha, small a, and x is a new variable, and gamma is b. So this is what we got. Okay. So as per this prediction, we got this new prediction. Okay. Then we need to specify the x predictions. What are the x predictions? Beta 1 or beta 2 or and so on. What is beta 1 here? Capital S, small b, capital S. This is the first beta 1 prediction. What is beta 2? This is the beta 2 prediction. Okay, this is beta 2. Next, what is third one? This is beta 3 bb. Beta 3 is bb. Okay, now this is what we got. Now this is our second production. But if you observe thoroughly here, there is a one more point which has been available over here. If you observe this X production, which is a new production, again this production has also been involved in the left factory. So how I can say, please observe over here. So what is the first symbol we have? Capital S. Now what about the first symbol present in the second production, which is also capital S? Now is it there available in this form, something like alpha beta 1 or alpha beta 2 or not? Now yes, it is available in the same form. Now that is the reason why now what we do, again we need to specify the, so we need to apply the left factoring. So here also I am going to write apply left factoring, or I am going to write some meaningful statements. Remove left factoring from this production. Why we say that we have a left factoring? The reason is we have the same symbol capital S which is appearing on our all productions. Now we need to remove the left factoring. So hence we are going to use capital S directs to capital S. This is the first symbol. Now I am going to introduce a new variable called y. Y, and here we are going to get gamma. What is gamma here? So BB is the gamma part. BB is the gamma part. Now we need to specify Y productions. What are the Y productions here? So beta 1 is capital SBS, or beta 2 is ASB. Beta 2 is ASB. Now these are the productions which will result in after removing the left factory. Okay, so the resultant productions after removing left factory. After removing left factory, or what are the predictions? This is our predictions. S derives to this one, and X and Y are like this. X and Y are like this. Understood? So this is how we are going to remove the left factoring present in the graph. Next, let us take one more example. We have plenty of examples available. Let us work it out with one more example. Now this time, this is our production. Have a look at this. So what is the symbol which is common in our all productions? You can see here we have AB, we have AB, and we have AB. Yes or no? Now what I can do now? I can take that AB as alpha. So S derives to AB as alpha. Now I am going to take AB, and I am going to introduce a new variable capital X, or, and this small a is going to act like a gamma. This small a is going to act like a gamma. There are two possibilities are there for this grammar. Let me tell you both the ways. Okay. So this small a is going to act like a gamma. And what about capital X productions now? So once you take out the AB part from here, now any which will left over here. So if nothing is there, in the sense the thing which will remain is a epsilon. So hence here the thing which will come is a epsilon. So epsilon first, then from this AB, if you remove AB part, then what will be the remaining part? Small c. So this will be small c. Or so from this AB, I mean from this ABCD, if you take AB part, then what would the remaining part will remain? CD. So CD is going to remain. CD is going to remain. Now if you observe thoroughly, again for this part also we can apply the left factory. So if you apply the left factoring for this, now what is common over here? Please observe we have small c and here also we have small c. So we have left factor. So we can apply the left factoring over here. So how do we apply the left factoring? Please observe small c and I am going to take capital Y. Capital Y is a new variable and this epsilon will come as it is as part of gamma, as part of gamma. And now we need to specify what is y is. What is y is. So from this CD, we have taken C out. So the thing which will remain is small d. And here from this production, if you remove C in the sense, the thing which will remain will be epsilon. Which will remain will be epsilon. Okay. Now these are the productions which will result in after removing the left factoring present in the grammar. So either this way also you can do. This is what I did. This is the first way. The other way is you can observe this. So this is our grammar. If you consider this. So from this grammar, straight away I can take that small a as the left factored part. So now what I do, I will take small a and I am going to call it capital X. Capital X, small a, capital X. Okay, and here in this production, I don't get any gamma part. Please observe because this small a is common, here it is common, it is also there, it is also there, it is there everywhere. So I don't get any gamma part. So now we need to write what is X. X will be, now we have taken a part over here. Now what will remain over here? The epsilon will remain. So here the first prediction which will be epsilon, and from here if you take out a, the part which will remain will be small b, and from this if you take out a, the part which will remain will be bc, it will be bc, and if you remove small a, then the part which will remain will be substring which will remain will be bct. Now, if you again look into over here, so this production will be again involved in the left factory. You can see here we have small b, we have small b, and this is also small b. And we have a gamma part like epsilon. Now, this can be again rewritten like, so these productions again we can rewrite like this. So how could we rewrite? So x derives to b capital Y epsilon. B capital Y epsilon. Why I have taken B? Because this is common for all the productions. Now we need to write what are the Y productions are. The Y productions are, if you take this B out, what will remain now? Epsilon will remain. So hence, sorry. So here we will get epsilon or from this BC, if you take B out, then what will remain? C will remain. Okay. And from this also, if you take out B, what will remain now? CD will remain. Now, if you observe thoroughly, again it is also involved in the left factor. So now I am going to take a new production. So Y derives to C capital Z or, and this epsilon is our gamma part. This epsilon is our gamma part. So I am going to take Cz. Now we need to write what about the Z productions. Z productions are, if you remove C from here, the thing which will remain will be epsilon. So epsilon or D. Epsilon or D. Understand? So for the same grammar, which you have taken above, now we are able to get so the productions which are in two different forms. You can see here. So this is also the our required productions after removing the left factoring, and this is also the our required productions after removing the left factory. Okay, so like this also you can do, or like this also you can go for removing the left factoring present in the grammar. Understand? Now if you want to work it out, you can try for this one also. Let us go for this one. what is this third production? In our third production, what we have common? We have IETS. You please observe IETS. Yes, we can take this entire part. So now here I am going to take, yes, there is two. I, small I, capital E, small t, capital S, X, or this gamma part is a small a. Gamma part is small a. Now we need to write X productions. What are the X productions? If you take this part out from this production, what will remain? Epsilon will remain. Epsilon will remain. So I am going to include epsilon over there, followed by. So from this, if you take out IETS, what will remain? Small e, capital S. Capital S. Now from this given production, we remove the left factory. And E derives to P is not involved in any left factoring. So hence we are going to write it straight away. Okay. So now the predictions which we are going to get after removal of left factoring will be like this. Okay. Then do the last one as part of today's class. Let us have a look at the last one also. So A derives to small a capital AB, and here we have small a capital B small c, and we have small a capital A C. Now if you observe thoroughly, either you can take small a as a left factored part, or you can take small a capital A. You can see here we have small a capital A, and here also we have small a capital A. Now what I do, let us take this part, small a capital A part, small a capital A followed by X, or the thing which is remaining will be small ABC. So this will be small ABC. So this, if you go for doing like this also, again, please observe what is the part we have over here. So we have small a comma. So better we go for taking small a itself as our left factor part, small a, and then capital X, capital X. And coming back to capital X, what is capital X? Capital X will be from this production, if you take out the small a, we'll get capital AB, or if you take out small a from this, we will remain capital B small c, or from this small a, if you remove, then we will get capital A small c. Capital A small c. Now from this, I hope now we can apply the left factor. We have capital A and as well as capital A, both are common. Now you can take this production like this. So capital A Y or B C. Capital A Y or B C. Where Y productions are, please observe what are the Y productions. Y productions are capital B or small c. Capital B or small c. Okay. Now these are our productions which we are going to get after removing the left factoring present in the grammar. Okay. So that's it for today's class, and where we have seen like how we are going to remove the left factoring and as well as left recursion present in the grammar. Okay, so let me repeat again. So the main reason why we are removing the left recursion and left factoring present in the grammar is, so mainly the parsers are not able to parse if the grammar is either ambiguous, or if the grammar is having either left recursion or left factoring kind of thing. So that is the reason why. So before going to give the context-free grammar as input to the parsers, so the first thing we have to confirm that the grammar is not ambiguous and the grammar is not having any left recursion and left factoring. So if you have either ambiguity, or if you have either left recursion or a left factoring kind of thing, the first and foremost thing we have to do is we need to rewrite our grammar in such a way that the ambiguity can be eliminated, and at the same time the left factoring and as well as the left recursion can be eliminated from the given grammar.